iron carbon equilibrium diagram. So iron carbon phase diagram is till, I mean, whatever the things that we have discussed here, that all were of the pure metal. Okay, pure metal of iron, right? Now, suppose that some other elements have been mixed together, and that is known as alloy. So here it is the iron alloy because the carbon is a different element that has been incorporated into the iron element. Okay, so iron is a pure and in which the carbon has been mixed to make them alloy. Okay, so now we are going to discuss the phase diagram of an alloy. And what the kind of the alloy? The iron carbon. Iron is the main solvent and this is the solute. Okay, this is known as and how their composition at different temperature will give the different phase that is going to be discussed in the phase diagram. So phase diagram, what is phase diagram means that you are basically having the temperature, okay, and so how you are reducing the temperature and increasing temperature, according to that you are getting the different phases. Okay, that is your phase diagram. So in case of the iron carbon, you have the iron and carbon, and mixing of them together is known as your alloy. And that alloy, how they respond, how they give the different phases according to the different temperature, that is going to be discussed in the phase diagram. Okay, so we have time. Not. Shall we start? Okay, let me discuss few points. So this is diagram. See, this is iron carbon diagram. If we have to take the name of the iron, it means iron would be 100% at this particular point. At this particular point, we have 100% iron. Okay. Now you can say that it is 100% carbon. No. Why? Because iron with carbon have a not 100% solubility. So what the maximum they can reach is 6.7. 6.7% of the carbon could be mixed with iron only. This is the maximum efficiency. You could say the solubility of a carbon into the iron is only 6.7%. Okay, so this is your basically saturation point. Saturation point means they have reached their maximum point. I mean, till further, if you will try to mix, they will not be able to mix together. Okay, this is their maximum solubility. Okay, so in case of you know carbon iron diagram or in a carbon iron alloy, you have only availability of 6.7% of carbon you can mix into the iron. So till 2%. See, mixing of carbon into the iron till 2%. If you have mixed 2% carbon, then this particular region is known as your steel. So what will be steel? Steel means the two till 2%. Okay, till 2%. If you have mixed the carbon to the iron, that particular material is known as your that kind of the iron or alloy is known as your steel. Okay, so what if you have exceed that 2% of limit? Okay, so till the 6.2% from more than 2%. So in between 2 to 6.7%, if you have mixed the carbon into the iron, that is known as your cast iron. Okay. So what is the cast iron? What is the steel? This is a very basic things that you need to know, which is the mixing of how much percentage that you have mixed the carbon into the iron. If it is up to 2%, then it is known as a though both are alloy of iron, right? Iron carbon. Okay, but if it depends on the percentage, as I've already discussed, and so far we have, come to this point that the composition plays a major role in any kind of the alloys. Okay, and if that composition will also affect the phases of that particular alloy as well. Okay, as I've already seen before in previous topic. So as you can see here. See, The temperature is same, 183 degrees C for PV, platinum, and SB, SN10. This is the alloy. Okay. So in the alloy of the PBSN, okay, what we get at particular temperature, which is 183 degrees C, we could get the two kind of things. Either we can get a eutectoid point and eutectic point. Both we can achieve. But it depends the percentage. Here you can see the 20% of what? 20% of SN is here present. Okay. And 80% is PB. So platinum is of 80% and SB, SN means the tin is of only 2%, right? But as we move forward at the same temperature, we have kept the same temperature, we move forward, then we reach at the tipping point. Here, just combination or composition gets changed. What is the ratio? The 60% is tin and only 40% is PB and platinum. Okay, so different compositions plays a very important role in any alloy, and that is of that can be seen from the phase diagram. Okay, so keeping the same temperature, we are having the different points because and different point means they have different critical point, and different critical points have different characteristics. Okay, so composition makes okay. One thing more. Here you can see SN is at 100% at the end, and PB is 100% at the beginning. What does it mean? Both are completely soluble in each other. It means they are having the 100% solubility. Okay, so one can soluble in another. But in case of carbon iron, that we have iron carbon, you can see here that we are not having that much of solubility. Only 6.7% can be uh, mixed with carbon. Okay, so keep in mind we will discuss the this iron carbon phase diagram in details in next class. Okay, but for now we have discussed a few points like what is a steel. If you have alloy of iron carbon in which the carbon is only 0 to 2%. Okay, obviously more than 0. Okay, so or less than 2% in between this region, then we are having the alloy of iron carbon is known as basically steel. And if you are having more carbon than 2% till 6.7% into the iron, and this type of alloy of iron carbon is known as your cast iron. Okay, so don't get confused with the cast iron. Means if the iron has been produced with the casting method, it's a very stupid things. Cast iron means how much percentage of carbon has been mixed with iron. Okay, so if it is more than 2% and less than 6%, 6.7%, then it is known as cast iron. And if the carbon is mixed with iron, 0 to 2% or less than 2%, then it is known as your steel. Okay, so we will discuss things later in the class. Okay, in details. What is iron carbon phase diagram. What the rest all points is here that we'll discuss. Okay.